Yeah, so as John mentioned, I'm going to do a quick demo on just our sort of workflow for getting an application kind of up and running for one of the users in the city. This is just going to be kind of a hypothetical demo. It's not going to be anything that we've actually done, but the workflow is going to be sort of representative of our bread and butter approach. First things first, in our sort of hypothetical scenario here, we got contacted by someone from the Parks Department. And what they want to do is establish a workflow to basically inspect and keep track of the condition of various park buildings. So one of the first things that I want to do in order to move the project forward is to kind of figure out what they are looking for in terms of the data set. What attributes are these building footprints going to need? What are they going to actually be inspecting when they send anyone out to go and do those inspections? And so to that end, I've put together a little form that I've been asking other city staff members to fill out that sort of just helps us write metadata. If you're anything like us, you might have a lot of sort of legacy data sets that don't have wonderful metadata explaining what all the fields are, who's the owner or the editor of this data. So I wanted to start to move us in a direction to solve that issue by sort of creating just a really basic metadata form. So it's going to ask, what's your layer name? What's the purpose? How is the data going to be generated if it doesn't already exist? Are we going to need to attach photos or do any kind of inspections or related tables? I just kind of went through this hypothetical data set, and we're going to have kind of a few basic field names here in our parent feature class, just a building name type in the overall condition status, which is going to be updated by each inspection. And then our related table attributes, these are going to be the inspection form that the field inspectors are going to walk through when they open the end result map in Field Maps. So again, pretty straightforward inspection information. Who did it? When did they do it? And since we have park buildings as our inspection feature, we're going to be looking at things like windows, doors, paint, structure, and then any additional notes that would be required. So that's sort of the initial process here. And in the real world, I've asked people to fill this form out twice now in the last couple months, so still pretty early getting to use it. One person pretty much understood what I was asking for with it, and the other kind of didn't. So I think this is going to need some refining in terms of explaining it to users who actually want to start generating some of this data. But that's what I have so far. Okay, so the next thing is to sort of think about the environment that we're working in here. So we're going to be doing these inspections in Field Maps, and we want the data to be updated automatically in our geodatabase. So these are going to be referenced feature services that we're working with. Right now, we are working out of our enterprise portal environment, which is an 11.1, and using the latest version of Arc Pro, which is a 3.1.3 at the moment, or at least that's what I have. And then we also have to think about our end users. So we know that the inspectors could be coming out of both the engineering or the parks department, which is one of the reasons why we want this to be web available due to sharing settings in our Microsoft Active Directory managed system. That means that certain users aren't going to have edit access to data that is created in a schema belonging to another department within the city. So we have to take that into account and publishing things to the web and doing all the editing there sort of gets around that that restriction. So we'll go ahead and open up Pro and get started. And so unlike Brett's really excellent presentation that he just got through, I don't have any slides. This is all just going to be a kind of a live demo. So please feel free to ask questions if any come up. And I suspect I'll be coming in a little bit under time, so I might have some time to answer those if you have any.
While it's loading, Zach, I'm going to ask the question I'm guessing we're all curious about, which is what version of Pro are you running right now?
Right now we're running 3.1.3, or at least I installed 3.1.3 on my machine a couple days ago. Everyone else is currently on 3.1.2, but we're trying to keep it sort of as up to date as possible across the deployment. All right, so here we are in the opening screen. I have a template that I use. I made this a while ago, and basically what this template is going to do is just sort of automatically populate a lot of servers and databases and folders and that kind of thing. That's going to help speed up the process here. So I know this is going to be a published referenced web service. And so in order to keep track of all of our projects, we have sort of a file folder system of organization. So I know that this is going to be an enterprise portal service as opposed to an AGOL service, mostly because it's internal. So I'm going to go ahead and save a new project right in here. And I'm just going to call it Park Building Inspections. Oh, back out of there. I'm just choosing a folder right now. All right. And so for reasons I haven't been quite able to track down, these newer versions of Pro checks this automatically. It's okay with me. Just got to pay attention to which folder I'm creating the project in. So this is on a network drive location, which is going to make it available to my other GIS coworker should either of us need to go in and make any changes to it. All right, so it's going to start out with our custom vector base map. That's what we sort of use as the default. But for now, I'm going to go ahead and clear these out because I know that our end users are going to want to see this over aerial imagery as opposed to a vector base map. So those layers no longer are pertinent to what I want to do here. Instead, I'm going to go to this folder that I already have mapped here as part of that template. And I'm going to boot up our most recent aerial and go ahead and add this to the map. And I'm going to remove this before publishing because it's not going to allow me to publish to our web server with this image in the map itself. Mostly this is just to help me figure out the symbology of the attribute or the features that I'm going to have in here. So first thing I want to do, get rid of some of these extra things that pop up. All right, so I'm going to go ahead and create a new database, and this is just going to be this project's working database. And I like to do that just for any like intermediate geoprocessing or testing that I have to do before actually moving anything over to our enterprise geodatabase. So we'll go ahead and create a new one. Going to make it the default. Save our project. Okay. So the next thing is going to be, I need to make a feature class that is based on that form that I had our hypothetical user fill out. So in my working geodatabase here, I'm going to go ahead and create a new one. I'm going to uncheck this Z values geometric properties. I've gotten tripped up a couple times. If you leave that turned on, there are some challenges to editing in a web environment. So won't worry too much about that right now. And then to save time, I actually have a pre-created version of this demo. So I'm going to take a little shortcut here. But so I just bring this in. It's got our feature types, feature attributes that we need here. It's got some editor tracking fields just because I had enabled it on that first feature class that I did when testing this out. So we're going to go ahead and pretty much just proceed through finishing the creation of that feature class. And I'm going to do the same thing with my inspection table. So I'm going to create a new table. See, we have the same fields here that our user had requested. And then what I also want to do while I'm still working on this here is I'm going to create the relationship feature or relationship class that's going to drive the inspection process. Actually, before I do that, I'm going to make sure that I have attachments and editor tracking enabled on. That's interesting. All right, doesn't usually happen. Let's close out of my other Pro project that I had open there in case that's holding a schema lock. Here we go. That was the ticket. All right, so we'll make sure that we have editor tracking and attachments enabled on both of these features. And then we'll go ahead and create our relationship class. Excuse me. All right, so we'll take our origin table, being our park building inspections, polygon feature class, and then our destination table is the actual inspection table. We want the ability to, of course, add more than one related record for any polygon. So we'll choose one to many, and then we'll use global ID from our polygon feature class and the GUID from our destination table to provide the relationship there. And then we'll just give that a run. Okay, so here's our basic set of features and relationships that we'll need in order to make the end result work. And what I'm going to do is actually import the previously drawn building footprints just to save a little bit of time here in this demo. So we're just going to run a quick append. So yeah, once again, this would not necessarily exist here yet, but I had to test this out to make sure it was working. So we'll go ahead and get all of those features in here. Okay, so I have a subset of park building footprints now ready to go. And my next step is to think about how I'm going to actually be viewing this end result in the field maps application. And so now that I have this aerial image under here too, I can sort of get a sense of how our field workers are going to be seeing these. And so I would spend some time here doing a little bit of fiddling with the symbology just to make it nice and easily readable. I'm going to actually add a folder connection because I spent some time on this a little bit ago here. So I have a layer file here that I'm going to use to style these buildings. So because I have this layer file, I can go to the symbology menu here and actually just import the symbology from another layer. And that symbology is going to carry across to the feature that I just created. So now they're going to be symbolized by this status field, which is what's going to get updated upon inspection by our field staff. The other thing I want to do, if I have the ability, is to do a little color vision simulator here. And this is just to check against these common color blindness possibilities. So I'm going to kind of go through these and just check and see how similar some of these features are going to look. It's never going to be perfect, but try pretty hard to find a color palette that's not going to create too much conflict. And I kind of like that one, at least for now. All right, so I have my map that has our building inspections, building footprints, which I'm going to rename for a little clarity. And now I want to remove this aerial so I can publish. And I'm also going to rename this map what I want the end result published web service to read as, since that's kind of the default that the hosting server will accept. And then it just makes it easier to find and overwrite the same web service if needed. Do a couple other things to set up our environment. I want to make sure that I have that checked, or else it won't let me publish. Show that again. That was kind of fast. So if you aren't familiar, when you publish a service to your web server, the REST endpoint is going to have a layer index for each layer that you have in your table of contents. Back in the ArcMap days, these were sort of non-adjustable, and they were just given an index in the order that they appeared in the table of contents. Now ArcPro has this nifty ability to actually just manually adjust them if needed. So we'll check that box just for data continuity and hit OK. And then I'm going to go into our park building inspections, because what I really want to do is add an attribute rule that is going to update our parent feature class when a particular, or when a new inspection record is added. And so let me kind of walk you through that really quick and show you what I mean. So I have our park building footprints, and they have the status column that's going to tell us the how the overall structure is looking in terms of condition. And the park building inspections table also has an overall structure condition column. So if a field staff member is going to go out and do an inspection, they're going to update this, and it's going to have a domain of the same options as our status column here in the parent feature class. So you can kind of see a scenario where someone might go out and do an inspection, fill out this whole inspection record, note a change in the overall quality of the structure here in the inspection table, and then just kind of forget to update the status in the actual feature class. Maybe they're in a hurry, maybe they're not super familiar with the application. So what I think would be really great is to guard against that possible data inaccuracy by making this automatically populate into this column whenever a new inspection is run. And we can use attribute rules to do that in theory. And I say in theory because I have a attribute expression that I swear should be able to work, but for some reason, it's either throwing an error or not throwing an error and just not working the way I want it to, or just doesn't actually, commit the changes. So if anyone has done something like this in the past with success, let me know. I think this would be a really great tool to use. So anyway, I'm going to copy and paste this attribute rule just to kind of show you what I want to have happen, even though the attribute rule would validate correctly, and then it's just not working for me. Anyway, so basically what I'm doing is I'm using this attribute rule in Arcade to get the parent feature class, and I'm getting the global ID and the status attributes. And then I'm filtering that data set by basically matching the GUID of our soon-to-be added record with the global ID of our parent feature class. So basically, when this rule runs, anytime a feature is inserted, this attribute expression should fire off any changes. So basically, we're just going to be sending an edit in the form of an update. And we're targeting this status feature from the parent feature class and giving it the value of structure here in the inspection table. And like I said, I haven't been able to get this to work, even though following the documentation I can find, it should. Yeah, like I said, shameless cry for help. If you know how to make that one work, I'd be happy to hear about it. All right, so we'll just get rid of that for now. But for the purposes of finishing up the documentation, we are almost there. Or finishing up the demo, I mean. So I'm going to go back to share, and I'm signed in to our enterprise portal. So I'm going to publish a web layer. I could give it summary and tags here, but basically what I'm looking at most importantly is this. So here is our publishing options. And we have publish as a map image, which will not provide editability. So we're going to make sure feature is checked. And if I wanted to publish this hosted, I would use this feature option here in the copy all data header. So I'm going to go choose a location, portal folder. This is just categories that I've created here for our environment. So this is going to be one of our primary service layers. And this is going to be an internal application. So this is on our hosting server folder structure. And then we'll set our sharing. So I've pre-created all of these groups based on the departments here within the city, as well as a couple other ones. But mostly what we need is the engineers need to be able to see this. Parks maintenance staff need to be able to see it. And we're just going to send it to our GIS/IT team as well. So we run into a couple of problems here. The first being that, of course, I still left these in our temporary working database as opposed to our enterprise geo database. So we're going to have to correct that, of course. And then a couple other small errors here where we need to change the display properties from shape length to something else. Okay, so get rid of that. And then I would take all of these and I would simply just copy and paste them into our enterprise geodatabase in the parks schema, since we're going to be looking at park buildings. And this can take a few minutes sometimes. So I walked through that publishing portion of the demo just a moment ago, and to kind of make sure we stay under time here, I actually have the end result here. So basically what I've done is I've created a new web map that has the same aerial image as the base map. And when it's an empty map, obviously there's not going to be anything in it. So I'm going to go to our REST endpoint on our hosting server. And I'm going to go ahead and grab our park building inspections feature class. Here's our layers with their indexes. And basically what I'm just going to do is copy and paste the URL of that REST endpoint and add it as a layer in the web map. So like I said, I already have it added here just for expediency, but you can see that since we add it from that REST endpoint and we've pre-configured the symbology, it just shows up right like we expect it to. It's following our symbology here in the web map, which is also an arcade expression that is basically just applying paired values to the different options in the domain in order to set this subset of options for symbolizing. So we have it here in our web map. And from there, I can further customize it by opening the Field Maps app and using the table formatter to make things a little bit easier on our field workers. But I think that's a topic for a different day because I know we're coming right up on time here. So yeah, if there's any other questions, that's kind of the bread and butter of our approach to getting a web map and application set up for our end users.